Good morning, friends. Today we will have a deep insight into the Aldol reaction. So, in this class, I will discuss the key points about the Aldol condensation. For Aldol condensation, the first one is the abstraction of alpha hydrogen. Abstraction of alpha hydrogen. Abstraction of alpha hydrogen. So, for alpha hydrogen abstraction, we use dilute base that may be sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide, etc. Now, we will have some discussion. Though alpha hydrogen is necessary for aldol condensation, I will discuss one example where there is no abstraction of alpha hydrogen. No abstraction of alpha hydrogen, still aldol condensation take place. Then we will discuss about the reverse aldol condensation. Reverse aldol condensation. At the end part, we will discuss about two types of aldol condensation. One is acid catalyzed, other is base catalyzed. Base catalyzed. One is acid catalyzed, other is base catalyzed. We will also have discussion about the intramolecular aldol condensation. Intramolecular aldol condensation. Okay. So, suppose and short tricks of aldol condensation. Suppose this is one acetaldehyde molecule. Two molecules of acetaldehyde in the presence of dilute NOH, they will give aldol products. So, how will write? This is CHO. I will write 2 hydrogen here in place of CH3. Now, the other molecule of CH3 COH I will like that. So, now I remove one water molecule. So, the product will be CHO, here one double bond CH3. So, the molecule will be CH3 CH double bond CH. This is the product of this reaction. Okay. So, in other way we can write, suppose there are two molecules CH3 CHO and HCOH, acetaldehyde and formaldehyde. So, here there is no alpha hydrogen, here there is alpha hydrogen. So, after alpha hydrogen abstraction will be done here, okay, and here attacks takes place. So, you can take the enolate first. So, CH2 CO minus H Now this inlet will attack the formaldehyde. It will done like this. So the product will be HCO CH2 COH. After heating, the product will be dehydration will take place. So it will be CH double bond CH2 COH. So we know about these reactions when it is whenever there are two types of reactants are there. So at that time cross Aldol condensation takes place. Crossed Aldol condensation. Crossed Aldol condensation if both the substrate contain alpha hydrogen, four types of products form. Out of two product by self Aldol condensation and other two product by crossed Aldol condensation. We will not go deep into the reaction because already we know these things. Now I will discuss one case where there is no alpha abstraction. For instance, consider the case CH3 COH. This is the functional group and this is the adjacent carbon to the functional group. So this is alpha carbon. So it has one alpha hydrogen. Okay. So in the presence of dilute base, what will happen? We are thinking it should be abstracted from here, but no, hydrogen will be abstracted from here. So how it will happen? CH2 COH. Now base will abstract this proton and it will come here. The resonating structure will be formed like this: CH CO minus H. This is the inlet formed the reaction. Now it will attack the other molecules CH3 COH. Now what will happen? It will attack here. Okay. So the structure will be, I will write this molecule here first: COH double bond CH2. Now it will attack here and it will form OH CH double bond CH3. Now after heating, this hydrogen will be abstracted. Heating, dehydration will take place and the molecule form will be CH. CO. This is the product form. Okay. So here there is no abstraction of alpha hydrogen. Still this reaction is more favorable. because why alpha hydrogen abstraction is taking place. If we will see the previous example, here alpha hydrogen abstraction takes place. Alpha hydrogen, after abstraction of alpha hydrogen, this enolate is formed and this enolate is more stabilized due to resonance. So, the main motto is the stabilization of the intermediate due to the process of resonance. So, instead of this alpha hydrogen here, if you are abstracting this alpha hydrogen, it is more resonating favorable. It is more this enolate form is more stable than this enolate form by the abstraction of this alpha hydrogen. Okay. So, this is one case where though alpha hydrogen abstraction is the primary process, here instead of this alpha hydrogen other hydrogen is abstracted, that means alpha, beta, gamma hydrogen is abstracted. So, this is one case. Now, we will little bit discuss about the rate of Aldol condensation, rate of Aldol condensation. Rate of Aldol condensation. So, step 1, suppose we will discuss about this for 2 molecules of acetaldehyde. So, what will happen in step 1? So, this is CH2 COH, here 3 alpha hydrogen, I am showing 1 alpha hydrogen for abstraction. So, in the presence of base it will happen like this. So, the structure will be CH2 CO minus H and H2. This is the enolate form. And step 2, with this other acetaldehyde molecule, this enolate will attack and structure will be CH3 CHOH CH2 COH. And step 3, on heating of this molecule, product will be formed CH3 CH CH COH. This is the product of this molecule. Now, it is the rate determining step or slowest step reaction. So, what we will do here, I will discuss about how. So, how we will write rate? Rate we will write equal to K for step number 2, CH3 acetaldehyde molecule concentration into CH2 CO minus H enolate concentration. We know in the rate reaction intermediate is not taken. Okay. You see here, this is the reversible reaction. So, this is the RDS, this reaction is RDS. So, in the rate reaction what you write? Rate equal to K into concentration of this aldehyde and concentration of this enolate. By we should not write enolate in the rate reaction. So, we will take this enolate concentration from this equilibrium constant. So, I first write K equal to, for step 1 reaction, K equal to what will happen? Enolate CH2 CO minus H water and acetaldehyde molecule and OH minus. Okay, so from this equation we will take enolate concentration is equal to K CH3 CHO OH minus. We will neglect the concentration of water because it is in more amount, so I will put here, you write K equilibrium here, K equilibrium, so K CH3 CHO in place of this enolate ion we will put this K equilibrium CH3 CHO OH minus. So finally K CH3 CH2 OH minus. Okay, so now what is the order of this reaction? Order of the reaction will be 2 plus 1. So 2 plus 1 equal to 3. So final conclusion of this, in aldol condensation, the order of the reaction is 3. Order of the reaction is 3. This is one more thing I want to discuss. Now I will discuss about some peculiar example. Suppose CH3 CHO and HCHO. This is one molecule, two molecules dilute, suppose sodium hydroxide. Now I am putting this molecule excess. Okay, then what will be the case? First there is the abstraction of alpha hydrogen forming the enolate CH2 CO minus H. Now it will attack with formaldehyde. Okay, now the product will be CH2 COH and CH2 OH. Okay, now again there is the again alpha hydrogen, two more alpha hydrogen is there, so what will happen? This the next step, the second abstraction of the alpha hydrogen takes place, and again the structure will be CH COH CH2OH again CH2OH. Now we see there is the possibility of one more abstraction of alpha hydrogen, so the structure will be CCOH CH2OH CH2OH CH2OH. Why? Because we are taking acetaldehyde in excess. That's why such type of peculiar product is formed. Okay, now we will take little bit about the reverse Aldol condensation. Reverse Aldol condensation. You take for instance this molecule. Okay, now I am putting OH, taking dilute OH minus, so it will abstract one proton from here, and as it is a 3-member ring, strand ring, so ring opening takes place. So what will be the product here? O minus, this is the structure. Now again it become neutralized in the presence of water, forming okay. Now this is a open chain structure. Now abstraction of alpha hydrogen takes place. Okay, so from here if it alpha hydrogen abstraction will take place, the form will be, ring will be 1 2 3 4 5. Okay, so what will happen? By abstraction of one alpha hydrogen, the inlet will be formed like that, and it will attack here. Now the ring will be 1 2 3 4 5. We make 5 member ring here. Suppose we'll numbering 1 2 3 4 5. So 5 1 2 3 4. Okay, so it will exist as first aldol. It will exist as first aldol. Then on heating, the product will be alpha beta. This is alpha beta unsaturated ketone. Okay, so this is one example where we took the reverse Aldol condensation. Where we took the reverse Aldol condensation. Okay. Is it okay? 1 2 3 4 5. 1 2 3 4 5. Okay. Reverse Aldol condensation. How many carbon? 1 2 3 4 5. It's okay. Reverse aldol condensation. Okay, what is left? Now we'll take one more example for intramolecular aldol condensation. Intramolecular aldol condensation. Intramolecular aldol condensation. So this is one molecule. Now there is alpha hydrogen abstraction. After alpha hydrogen abstraction, this is the intermediate. Now this will undergo cyclization. So how many? 1 2 3 4 5 6. Okay, so the 6 member ring will be formed. So 1 2 3 4 5 6. In the place of 3 there is one OH. Now this on heating will form alpha beta unsaturated ketone. Alpha beta unsaturated ketone. Okay, suppose, so what we come to know in the intramolecular aldol condensation, or in other cases the abstraction of alpha hydrogen takes place from the less hindered position, here or from here, and forming the 5 membered or 6 membered ring, because these are usually more stable. Suppose if I will change this substrate molecule like this, CO 1 2 3, then you might think abstraction of alpha hydrogen takes place from here. Okay, for instance, let us say alpha hydrogen abstraction takes place from here. So this is the intermediate and cyclizations will take place. So what will happen? 1 2 3 4 5 6 7 8. So what happened now? 1 2 3 4 5 6 7 8. So 8 member ring is forming. Okay, again I am drawing 1 2 3 4 5 6 7 8. Okay, so here 1 2 3, in the position of 3 there is hydroxy group. Okay, so after heating it is supposed to form 1 2 3 4 5 6 7 8 like this, but this is a 8 member ring which is more strained, so not possible to form, not possible to form. Okay, so in such cases where there is probability of formation of more strained ring, either 3 4 or 7 8 like this, in this case we will prefer the abstraction of alpha hydrogen from little bit comparatively hindered position. So this route is not possible. So what we will do? So this route is not possible. So what we will do? Now the abstraction of alpha hydrogen. Now the abstraction of alpha hydrogen will takes place from here. Here. So we will write the inlet. Okay. So now the cyclization take place. So we will numbering from 1 2 3 4 5 6. The molecule will be, this is outside the ring. So from this 1 then we will write 6, then we will write 5 4, then 3, then 2. So in the 6 this is hydroxy group, and which on it heating will form the alpha beta alkene. So this is the gist of this intramolecular aldol condensation. Whenever there is formation of more stable ring, we will prefer abstraction of alpha hydrogen from the least hindered position. This is because this is more favorable for abstraction, and if by this position process we are getting very less strained ring, then we have to do the abstraction from little bit comparatively hindered position, so that the formation of ring will be more stable. Okay. Intramolecular aldol condensation is over, reverse aldol condensation is over. Okay. This is all about the aldol condensation. It is little bit deep discussion about the aldol condensation. Okay. Goodbye.